Alright, so this is the first official episode of the series Data Structure and Algorithms. So today we're going to talk about array, the most basic data structure possible. So basically there are two types of arrays, the static array and the dynamic array. So in these lessons we're going to discuss some basic idea about these two type array, the static array and the dynamic array. In C or C++, the static array is created by a declaration, for example, int rr5, which creates an array of 5 integers. Whereas for dynamic array, you can invoke it by include vector header file. Okay, so these slides demonstrate the difference between the two type arrays. The static array is a fixed size array, whereas the dynamic array is an array with no fixed size. So in the left hand side, you can see that we allocated 5 memory blocks for the static array in the memory region. So because we only allocated 5 block memory for the array, when the sixth element or the sixth integer is added to the array, the addition cannot be happen because we are run out of memory. Whereas on the blue part, on the right hand side, when the array is ran out of memory, it can double its size by the grow or resize functions to double the size of itself. In this case, the size of the array grow from 5 block of memory up to 10 of block memories, which is double of 5. And then you can see on the right hand side, there are a lot of blocks of memory for the number 10 to be allocated in. So the number 10 gonna fill in to the memory cells after number 2, which is an empty memory cell. So now you can see for the static array, the number 10 cannot be allocated into the content of the array because it has ran out of memory. Whereas due to the free blocks of memory available on the dynamic array, the number 10 can be allocated as the sixth element of the array due to the free memory blocks that is available. So in comparisons of a static array and dynamic array, both have the very fast query time of 01, but then the difference start to show. For the static array, it is a fixed size structures as you have seen before, whereas for the dynamic array, it's a resizable structure. The size of the dynamic array can be double or grow by a factor defined by the programmer themselves. The next difference between the static array and the dynamic array is the memory allocations. The static array is allocated, its memory is allocated at compile time, whereas the memory of the dynamic array is allocated at runtime. And about the location in the memory region, the location of the static array is entirely in the stack section of memory, the stack memory space. The dynamic array, which is called the vector, has the object of the array lies in the stack section of memory, but the data inside the vector or the dynamic array is dynamically allocated on the heap section of memory. So we can clearly see that where each type memory, each type array lies in the memory structure of computer is different already. This is the code for an static array in C++. So before we talking about dynamic array, let's talk about static array in C++ first. So here, first of all, the static array has to have a predefined uh, uh, space capacity, I mean memory capacity. In this case, we have to allocate for the array 5 block of memory, which is 5 times 4, which is 20 uh, bytes, because each of these block is 4 byte of memories for the integer data type. And then you can allocate the content of each memory cell by just normal assignment using indexing. So for static array, the index gonna be starting from 0 to size of the array -1. So in this case, we have 5 elements in the array. So the indexing gonna go from 0 to 4. Okay, so now let's compare the static array with the dynamic array. And here's the example code for a dynamic array in C++. As for now, let's assume that the vector library in C++ is actually a dynamic array. To avoid complexity at this stage, let's assume that the include vector gonna give you by default the dynamic array. We're gonna discuss the exact content of the include vector library in the following episodes. So for this dynamic array, you can see that we don't have to declare a fixed size for the array. So each time we want to assign a memory block to a number, we just have to push back that number into the memory array. And then we can automatically count how many elements are there in the dynamic array by the array2 dot size functionality here. And when you run a for loop from 0 to array size -1, you're gonna print out all elements of the array as you have seen on the screen. And to recap, uh, on this example, we're gonna use the include vector library to activate the dynamic array for simplicity. So as you can clearly see here, the dynamic array don't have to be declared a maximum capacity, because virtually each time you run out of the memory with the dynamic array, the capacity gonna double, so that it ensures that you're gonna always have a free memory block to allocate new data in. So you can see that in this case, the array2 dot size is only a measurement of how many blocks of memory has been allocated, whereas the actual capacity of the array is not being fixed. Okay, so in this episode, we're going to talk about the difference in behavior between the static array and a dynamic array. So you can see on the left hand side, we have a static array, and on the right hand side, we have a dynamic array. Seemingly, the data for the two arrays are the same, just mere integer 1, 2, 3, 4, 5, and the queries is also the same. So we're gonna do two queries for each array. First of all, we're gonna query for the memory block from block 0 to block 4, and the second query is for memory blocks from block 0 to block 10. I mean block 9. And the second query gonna be for memories blocks from block 0 to block 9. because I run from 0 to 9. In this case, I is less than 10, so I run from 0 to 9. So you can see that already the difference in behavior of these two type arrays. On the left hand side, on the first query, the two arrays behave the same. They just print out 1, 2, 3, 4, 5, which are the assigned value we input into each array themselves. Whereas for the second queries, the static array produce some garbage value for index from 5 to 9, whereas the dynamic array on the right hand side gonna produce a lot of zero, not garbage value for index from 5 to 9. So the static array gonna produce some garbage value for overrange query, whereas the dynamic array gonna produce some initialized value for overrange query. So you can see here, the static array is uninitialized. Therefore, they're gonna return us for some garbage value for overrange query. Whereas on the right hand side, the dynamic array has already initialized the overrange query block. So we're gonna return 0 instead of some garbage value. So for the next part, I want to discuss about the application memories and how this memory region of the architecture is linked to the two type array we have discussed before, the dynamic array and the static array. So we can see here on the screen there are some portion of the application memory. Yeah, the stack section of memory, the heap section of memory, the static or global section of memory, and the code or text sections. So there was some other memory region like the uninitialized data, the BNS, and the initialized data like the OS. But the general idea is that the stack section of memory gonna be lying above the heap section of memory, and the stack section of memory gonna going downward, whereas the heap section of memory gonna going upward. So the static array gonna stay on entirely on the stack section of memory, whereas the dynamic array is being split. The dynamic array object gonna stay on the stack section of memory as well, whereas the data inside the dynamic array gonna lies on the heap section of memory, which means the lower the address memory regions. So now we're going to do an experiment to see whether our theory is correct. Previously, we say that the static array and the dynamic array object gonna stay in the stack section of memory, and the data inside the dynamic array gonna stay in the heap section of memory. Now, there's a fact that any address associated with the stack section of memory gonna have the memory address of 0x7ffc or 7f, whereas any address link with the heap section of memory gonna be something like 0x55f or 06f or 0x56, something like that. Because basically the stack memory region is lying on a higher address, and the heap memory region lying on the lower memory address. So to recut, any address like 0x7ffc gonna be linked to the stack memory section, whereas the address of 0x55f0 or 0x56 or 0x6f gonna be indicator of the heap memory regions. So let's run an experiment. So in this experiment, we have two arrays. The first array is array R, array 1, which is a static array of 5 elements. And we can see that this static array of 5 elements lie explicitly on the stack section of memory, because the address of the array object, address of array 1, the entire array, is on the stack section of memory with the address of 07FFC, and also the data, I mean the address of the first element of the array is also lie on the stack section of memory, as the address for the array 10 first element is also 7xFFC. In contrast, the dynamic array has the split in the memory region of allocation. The vector object on the dynamic array object lie on the higher portion of memory, the stack section of memory, indicated by the address of array 2 vector object as 0x7FFC, whereas the data for the vector, the data for the dynamic array lie on the heap section of memory. You can see here on the last line, the address is 0x56, which is a lower section of memory, and the indication of a heap allocations as is a 0x56 address, as we have discussed on the previous slides. So that is a recap of the dynamic array versus static array lecture. To recap, the dynamic array has infinite amount of memory space, whereas the static array has only a limited or assigned predetermined memory capacity. The static array lies explicitly on the stack section of memory, whereas the vector object of the dynamic array gonna lie on the stack section of memory, whereas the data for the dynamic array gonna lie on the heap section of memory. In the next episodes, we're gonna discuss what is the actual mathematical model or say data structure behind the vector library, which is the explicit mathematical model of a dynamic array. Until then, see you later. Thank you very much.